In today's session of this non-destructive evolution, we'd like to discuss regarding the advantages, limitations, and some of the applications related to the ultrasonic testing process. Before moving on to the advantages, I would like to process the discussion related to the data presentation in the experimentational process, as is a small topic that has altered due to the lack of time in the first phase class. So here we all know that the impregnation of sound waves at different frequency levels in order to identify the defects existing within the materials at various fields of the examining point, the industrial sectors, medical fields, etc. So the input has been given in the form of an programming that leads to the impregnation of the sound waves at the desired frequency levels to the system or to the work parts. You need to examine it. Furtherly, the equipment such as this transceiver plays a major role, which is containing the piezometer, which is indirectly having in contact with the equipment or work part and need to measure the desired parameters over it. After examining in the receiving strategy, the signals will be grasped from the piezometer that has been identified within the work material or work part which we need to be examined will be represented in number of different formats. They are having three common formats: A scan, B scan, and C scan. We'll be looking after in detail one by one. A scan presentation displays the amount of received ultrasonic energy as a function of time. So with respect to the time variant, the ultrasonic energy in the form of an wave representations or fluctuations will be getting progressed. The relative discontinuity in its size can be estimated due to the damping sections or amplitude variations at different frequency levels will be identified in the CRT screen. And the depth of the reflector, which is determined by its position on a single horizontal sphere. Coming to the B-scan process, the presentations display a profile view such as the cross-sectional view, which will be commencing on the visualizing detailedly on the specimen. Here, within that cross-section, the linear dimensions can be determined based upon the reflector depth of its penetration that the waves represents towards its depth and the linear dimensions can be clearly determined within the object. But it's having one of the defect that the display technique, it may be masked by large reflectors which are acting or which are existing in the nearby surface levels. So those will be getting masked due to the uplit stream and can't be visualized as clearly as the surface level cracks came into the picture, as we will be as we are visualizing in the surface layer, base surface layer of the object. Hence, these are the crack representations or flaws that will be identified very much clearly up to a particular depth of penetration. And subsurface levels and the underneath surface levels do not give the a clear-cut vision as per this. B-scan data representation is being processing in the on the coming to the third representation, there is C-scan representation. In this C-scan representation, it displays in a type of execution, or nominally we'll be calling it some plan type, which we need to progress in the nearest future. A sequence of steps will be planned according to it to view the test specimen and even the discontinuities which are having within the specimen. Even the C-scan representations which are produced with the automated data acquisition system, which is directly connected towards the control system. Nothing but we can say that the control system is placing a major role in need to operate and examine by the impregnation of this C-scan process, such as immersion scannings. We are aware of this immersion scanning, that in this process the entire specimen will be dipped into the aqueous solution, which is a chemical compound composition liquid offense that will identify clearly the surface and the underneath subsurface levels without having any of the air gaps or air medium traveling between the testing tool and the test piece, or nominally we'll call as workpiece. So within the solution, there is no chance of entering the air gaps and deteriorating the values. By this, we'll be getting the results in an high efficiency range, and nominally we'll be calling high accurate results will be generated. And even using of the A scan in conjunction with the C scan is also necessary when the depth determination is decided. So to the surface levels and the subsurface levels, the C scan representations or utilization of this C scan processing with a less amount of frequency sound waves is sufficient nominally for calculating or observing the defects at the time of immersion technique we are being utilized. But even furtherly, very much depth of constraints, nothing but entire the object need to be verified clearly from top surface to the end surface of the object. So in such a cases, without allowing the gaseous or else even the normal atmospheric conditions, slightly will be an incremental at altitudes with respect to the temperature and conditions. It may leads to two different stages also. That is, in an high temperature way of identifying in some of the materials, and even it can be leads to the cryogenic system of measuring the entire objects in case of its surface finishing or else any of the defects such as cracks or air bubbles which has been commenced at the time of casting process, and even different types of techniques such as welding techniques at fusion state and fusion state which has been commenced at various types of joints, either it may be of butt joint, lap joint, lamellar types of joints, V, T, double V, etc. So the C scan, that is nothing but the frequency of the sound waves which are limiting to a particular extent of depth of penetration within the liquid medium. But the utilization of this A scan with respect to the C scan, which is having the high frequency levels, and even we can say clearly that A scan system of acoustic waves having the highest frequency levels which clearly examine the overall component even though its thickness is being increasing in a wide range. So hence here is a clear-cut representation for us that use of A scan in conjunction with C scan is necessary when depth determination is desired. So you need to identify clearly the overall visualization of the objects, that too to a maximum depth levels. The high frequency sound waves should be utilized that are possible only with our A scan systems. Coming to the point of the advantages of ultrasonic testing process. These are very much sensitive for both the subsurface and surface discontinuities identification. So here we have utilized the word that is sensitive. So we all know that even for an micro level of calibration also, full-fledgedly the results will be examining in this particular technique. Nominally, external offense of identifying dimensions leads to an acoustical conditions obeying in manufacturing. But in almost all the cases, I mean, in different types of applications also, it is very much sensitive to identify both the surface levels of the object as well as the subsurface levels of the object. Not only in the case of this discontinuities, but its roughness in the surface and how much heights and depths, nothing but crusts and troughs that are being occurring at a micro range and even in the macro range at the surface levels if the non-linearity conditions has been maintained in the machining processes. And rest of the conditions, the air voids which has been arrested at the different layers of the object which has been identified internally while the casting process has been commenced. So we all know that the hardness will be very much affected due to the applied load conditions from the external sources if those air voids or else or any of the discontinuities in the form of unfilling of the material, air backups, nothing but the pores situations or cracks are identified, or else any of the unwanted material other than the required material, nothing but the functionality of the material, composition of the material to the other material if it is anyone happening while the casting process has been commenced. So hence, even those defects also very much clearly identified, and even its range also in the case of dimensions, the discontinuities range also clearly identified by the ultrasonic testing methodology. Coming to the second point, that is depth of penetration for flaw detection or measurement is superior to the other methods. See, we have till now we have learned the radiographic technique processes. In that, X-rays, Y-rays, and gamma rays we have been studied, and its ranges are limited to only some applications. And coming to the accuracy point in the measurement strategy, the radiographic technology in the case of engineering fields, particularly in the case of in the engineering field, it is limiting to some extent. But whereas in the medical fields it has been considered, it's having a high scope of examining clearly the internal objects. First example, the X-rays will be seeing normally in the hospitals also. Hence, for an engineering object such as solid objects which need to be examined, such as the parts which will be utilizing in the case of these automobiles or aviation technology, or the domestic appliances which are being manufactured within the industrial sector, is limited to heavy examining conditions. Either it may be in an enclosed conditions or else in the temperature operating zone conditions or else manufacturing regions. Qualitative and quantitative identification also will be limited to its penetration levels of the projected light beams which are being entering in the case of radiographic technology. The other technique that we have been seen, that the liquid penetrant test, that is limited, that particular test itself, it is limited to only the surface levels of identification at each and every face levels, that is top view representation, bottom view representation, front view representations, back side view representation, side views, that is left side view and right side view. So for a cuboid object, the three-dimensional object will be having the six different faces, and almost all the six different faces can be clearly examined only to a surface level of cracks or else any of the voids that has been occurred, and even at the edge considerations also, considerations, but not to the depth of its penetration to the internal cracks identifications when the casting process has been considered. This liquid penetrant testing process is limited to its examining conditions or examination process, because the liquid, or either it may be of an acidic type of solution or basic type of solution that we have been utilizing, that cannot be emerged by reacting with respect to the concerned material which we are identifying or which we need to examine, and will not enter into the internal depth of the layer conditions in the case of this liquid penetrant test. But even in the next examining process, in the previous classes we have discussed the magnetic testing process also, and even the magnetic field at a particular frequency from the primary coil to the secondary ignited, or due to the concept of this mutual induction concept and the providing of eddy current process, will limits to its magnetic field due to the input conditions of electrical power supply, and the voltage fluctuations will be getting occurred, and limits for its penetration at that particular identification zones. But in the case of this ultrasonic testing process, it doesn't have that limitations in according to the penetration levels within the three-dimensional objects also. Even though it's in the vacuum region, or the object which is already holding a particular offenses, that too in any of the offensities or any of the phase of the material it is, either it may be of a gaseous medium or liquid medium or else the solid medium. So gaseous medium will be having the very much low density, a liquid medium a moderate density, and the solid medium will be having the high density objects. And based upon these three levels, the properties will be getting varied by reflecting with respect to each and every phase levels. But this ultrasonic testing is the best source of examining process, can be processed in three different phases and identify the composition of the materials even in the gaseous state, in the liquid state, or else even in the solid offense also. So the sound waves are having the capability of moving or interacting or identifying the entire phases with respect to the required dimensions, or else the class identifications or air gaps in the case of this solid offenses. The composition levels can be identified clearly, and overall detections can be processed with superior strategies when compared to the above methodologies, just as we have been discussed, such as the radiographic techniques, echo testing process, liquid penetrant testing process, magnetic testing process, etc. Those are limited to some extent only to surface levels to some extent and subsurface levels, and only to a particular depth of penetration, that is maximum of 6 to 12 mm of thickness, can be examined. And the application oriented strategy, radiographic technology, that is biological hesitation, is very much important, and having the high scope in the case of biological identification or detecting. But this ultrasonic plays a major role need to identify the overall considerations. In almost all the strategies, it has its own trend of examining the overall properties and defects within the objects. And another one more strategy that is only the single-sided access is needed when pulse echo technique is used. This is one of the major advantage here, that the pulse echo technique, we are utilizing this calibration device, and it is having the dual functionality. There is a greater advantage in the case of this ultrasonic testing process, which it itself has inducing the sound waves at an desired frequency levels and receiving the similar results by the same device. Hence, trans receiver, which is a combinational devices which has been connected mutually, piezoelectric devices, both the piezoelectric devices, which one you will be utilizing for the transferring of the signals for penetration, and after examining receiving the results oriented piezoelectric device. Hence, by energizing or examining only from the single side also, we are accessing the complete analysis over that entire equipment in the three-dimensional strategy. And another one more advantage it is high accuracy is achieved in the reflector position, and the entire dimensions of the objects can be examined, and even those can be estimated if at all the objects are exceeding the levels of its depth of penetration. It can be examined. So when compared to the previous technologies, previous non-destructive evolution techniques, this ultrasonic testing is having a much more depth of penetration, but beyond the limitations, it is having the examination factors. Those also can be nearestly can be examined or estimated by this ultrasonic testing process. There's a greater advantage here will be coming across. A minimal part preparation is required, but not to a maximum level. Coming to the electronic equipment, such as this calibration process and data impregnation in the form of a frequency waves, sound waves, generation of the frequency sound waves, impregnations, passage, and scanning systems by utilizing any one of the techniques such as E scan, B scan, and C scan systems. Instantaneously within a fraction of minutes in the macro range, and even in the fraction of seconds in the case of even the micro range, is also having its own strategy of finding the results in the case of this ultrasonic testing process. Even the capturing accesses are also possible, which have the capability of producing the automated with respect to the automated control systems that has been provided as an programmed devices within the control system itself. So the images will be captured up to which depth of penetration the sound waves has been produced, and the elevated cracks or identified defects and its dimensions also will be captured in the form of an image for good accuracy signal formation. And even it has some other benefits or advantages such as thickness measurement. Normally we will be calling as an gauge length measurements in our mechanical language with respect to the flaw detections and the geometrical specifications. So these are the advantages in the case of this ultrasonic testing process. Coming to some of the limitations towards it, as we have been already discussed, that when compared to other techniques, it's having a wide range of depth of penetration, but even will be having minute to its levels, minimized or exempted to a particular levels of penetration. Hence, the limitations here are surface must be accessible to transmit the ultrasound. Hence, the surface should be enabled to transmit, and even another one more thing, that's a recipient also, because only the one side of generating of sound waves and penetration is accessing, and in the same way the piezoelectric meters are fixing in a combo level for both the transferring and receiving the signals. Hence, the surface should be a very good accessing in the case of transmission and receiving the ultrasound waves. Second thing, only the skillful person can be operated over this particular ultrasonic testing process. Indeed, to get the accurate results with respect to the standard results. So the obtained results will be compared with respect to the standard results as per the ASTM standards, as we have been referred in the previous days classes. Hence, to be the known representation, skill and training is more extensive when compared to the previous methodologies. Hence, only the skillful worker is allowed to operate over this ultrasonic testing process for examining the required parameters. And the materials which are having the rough surface finishing and irregularities in its shapes, and even which are very much small, without utilizing the microscopic technology, the materials which are having very much small in its dimensions, and these are exempted in the case of processing this ultrasonic testing process, because in the micro range the mode of ultrasonic test need to be transferred initially, which leads to an high economical factor. So, but only, hence we can say that only the macro ranged, but not in micro, only macro ranges of objects, specimens are used to measure to its detections or to identify the defects in the case of this ultrasonic testing process. Cast iron and other coarse grained materials are very much difficult to inspect because of low sound transmission and high signal noise will be getting occurred over it. Because the steel has a good recipient and the generation of the echoes, it leads to an differing in the signal strength based on the internally generated echoes due to the input echo, because of finding or because of the composition of this carbon content in the composition of the materials very much high in range when compared to the non-metals, non-ferrous content of metals, and even the non-metals. The linear defects which are oriented in parallel to the sound waves will not be getting detected because the flow conditions will not be getting identified in the same direction and magnitude of the flaws also. Hence, the reference standards are required for the comparison and indeed to identify the characteristics of the flaws. For best our understanding, so far we have been discussed, we'll be moving on to N1, example related to the industrial sector. Considering a big market research is a pictorial representation which is having identifying its input consumptions and output exertions related towards the industrial parameters which are being utilized. So the global ultrasonic testing machine is related to the 2016 manufacture, related to the market research. We'll be discussing regarding the consequences of this report. In this industry, the report will be giving towards the market analysis by the market analysts related to the inputs from the industry experts. What are the targets or what are the strategies to be maintained? What are the parameters to be followed? And what are the materials to be increased? And what are the research activities to be done? What are the classifications related to the products? And based upon the types of applications, the inputs need to be increased in order to create a better efficiency or better benefits to the end users. And even though upon creating these, by providing these many of the benefits to the customers, it should not be impacted in the case of this cost or revenue, which is incrementing in the product cost. So it should be obtained to an same cost which is available presently within the market, but the benefits related to the end user should be increased. So there is a survey, and for that survey, a chain linkage that relates to the marketing sector and to the production units, which the strategies will be getting adopted indeed to strengthen the quality of the product in the manufacturing area, and nominally which leads to a high demand oriented product in the marketing sector. So for that, studies makes an analysis regarding this business strategies which need to overcome to grow in the industry. Finally, the conclusion statement is that a feasibility of new investment projects is accessed. So when you are giving the high benefits and with a same cost of the product which is available within the market presently, and additionally to the existing benefits, additional benefits are give if you have been providing, automatically the demand for the particular product will be definitely increasing within the marketing. So for the chain linkages need to be identified as we have been discussed, and those should be reported in a form of description and should be analyzed twice or thrice by referring with respect to the standards. If at all it reaches into the marketing strategies, automatically will be selected towards the investment related to this projects. So this one of the report can be analyzed by utilizing this incrementing in the benefits by utilizing this ultrasonic testing process. Thank you. We will be meeting in the next class.